Now that we are familiar with algebraic expressions, we'll focus our attention on a specific type of algebraic expression called a polynomial. In section 1.2, we'll examine operations on polynomials, including addition and subtraction, rules of exponents, and multiplication with the distributive property and FOIL. In this video, we're going to focus on adding and subtracting polynomials. Now, there's a lot of terminology associated with polynomials that you'll want to be familiar with. To begin with, a single term in an algebraic expression contains a constant, a variable, or a product of a coefficient and a power of a variable or multiple variables. For example, 2 is a single term. We would call that a constant. It's just a number. It never changes value, so it is constant. Or another example is the single term 3x squared. It has a constant coefficient. The number to the left of the variable is called the coefficient, and a power of the variable. And also, negative 1/2 xy cubed is a single term. The coefficient there is negative 1/2, and we have more than one variable. Now, the sum of several terms is called a polynomial. For example, 2x cubed minus 3x squared plus 5x minus 1 is a polynomial. In this case, we have 1, 2, 3, 4 terms composing the polynomial. Specifically, a monomial, notice the prefix mono, meaning one, contains one term, like all of our examples up here. A binomial, the prefix bi means two. Binomial contains two terms, and a trinomial, as you can imagine, contains three terms. When we have a polynomial with 4 or more terms, we simply refer to it as a polynomial. Polynomials are written in descending order with terms arranged from the highest exponent to the lowest exponent. In our example here, we started with the highest exponent of 3, and that decreased to 2, to 1, and then exponent 0 on our last term there. This is what we call standard form. Now, like terms contain the same variables raised to corresponding exponents, though they may have different coefficients. For example, 2x squared and 5x squared are like terms. They have different coefficients, but their variable parts match. While 3xy and 2x are not like terms because their variable parts do not match. To add or subtract polynomials, we combine like terms. When subtracting polynomials, remember that you may have to apply the distributive property. Let's practice adding and subtracting polynomials by combining like terms. On example 1, we want to find the sum or difference of the polynomials and write the result in standard form. Remember, that means descending order. On the first example, we have the sum of two trinomials. Now, the parentheses in this problem are not making a difference. So on the first step, I'm just going to drop those parentheses. Then our goal is to identify and combine like terms. Addition is associative as well as commutative. That means you can apply it in any order. So I'm going to take this first term, 3x squared, and observe that it has a like term down here on the end. The coefficient there we can understand to be 1. So we'll execute 3x squared plus 1x squared to get 4x squared. Next, we have like terms plus 2xy and minus 8xy. Plus 2xy minus 8xy gives me negative 6xy. And then finally, we have two constants to combine, negative 5 plus 7, and that gives us plus 2. So our simplified polynomial there, 4x squared minus 6xy plus 2. Now, subtraction is similar, but when you have a set of parentheses preceded by a negative, we have to distribute that negative to each term inside parentheses in order to break up those parentheses. Now, around the first binomial, the parentheses are not making a difference, so I'm just going to drop those. Distributing the negative into the second trinomial, we have negative 2x squared plus 7x plus 4. Our goal now is to identify like terms. I'm going to start with the highest exponent, negative 5x squared. Combine it with like term, negative 2x squared. Negative 5 minus 2 gives me negative 7. So those combine to give us negative 7x squared. I'm going to go for the term with the next highest exponent, which is 7x. It does not have a corresponding term, so that'll be my middle term. And finally, we combine the constants, 2 plus 4 to get 6. And that is our simplified polynomial. I want to make sure I box both of my answers. All right, that is the introduction to polynomials and adding and subtracting by combining like terms.